Good morning, everyone. I just did up a sample graph here for anyone who's working on your journal project and is ready to try to calculate your equation on your own. If you have trouble with this, I'm happy to help you tomorrow or Friday, but I wanted to give you a chance to try to work it out on your own. I'm going to show you exactly what I did. I came up with a set of data here. It's imaginary data, but I imagined what it would be like after school gets out. The number of hours of sleep per night that somebody might get after school gets out. And I started with on day 0, which would be like the last day of school. I started with day 0 at 6.5 hours of sleep. So there's my y-intercept right there. 0 and 6.5 is the first data point. And then it went up a little bit to 7 hours, and then it stayed 7 hours, and then it went up. And after I get like 3 good nights sleep, I often don't get a very good night's sleep. So then it drops down to about 6.5 hours. And I realize most of you probably sleep like 9 hours a night, but I sleep about 7 or 8 max on a good day. So the days fluctuate a little bit like a natural sleep pattern might. You might sleep well one night and you might not sleep well the next night. But gradually, as the summer starts to progress after school gets out, I'm sleeping more and more each night, which is typically what happens. I get better sleep during the summer than I do during the school year, and I bet most of you do too. So what I've done is I created a linear model of that data. I took my first data point and my last data point and the ruler, and I made a line directly through those data points to try to kind of get it as close to the data points as possible. And it's going upward. And then I found a point at the very end of the graph on day 18. There are 9 hours of sleep on that day. So we start at 0 and 6.5, and then we ended at 18 and 9. And those 2 points are going to be really important in trying to calculate my equation. So let's move over to this paper here. All right, so I recorded the y-intercept as 6.5. That's going to be the end of our equation. The y-intercept is always reflected as the number added or subtracted at the end of a linear equation, written in slope-intercept form. And then I'm using this formula to calculate the rate of change, which also shows up in the equation. This formula is the second y value minus the first y value divided by the second x value minus the first x value. And those are the values of points. So I use those first 2 points, the 0 and 6.5, as my first point. That's x1 and y1. And I use that second point over here on the graph, 18 and 9, as x2 and y2. And I put them in this formula. So I have 9, that's y2, minus 6.5, that's y1, and then 18, that's x2, minus 0, that's x1. And I got 2.5 over 18. And when I put that into the calculator, it was 0.13888 repeated, and I rounded that to 0.14 for convenience. So that's my rate of change, and that's going right in my equation. So the equation is going to look like this. 0 equals 0.14x plus 6.5. That's my equation. And then with that, in order to create my table of data, I use the first data point, the y-intercept, 0 and 6.5, and my last data point that was already on the graph, 18 and 9, as 2 of those points. And then I created another series of points by taking the x value and plugging it right into my equation, and using a calculator, I took 2, multiplied it by 0.14 in the equation, because 2 is replacing x, multiply it by 0.14, and then I added 6.5, and I got 6.78 for night 2. And then I decided on day 5, I would put 5 in for x, 5 times 0.14 plus 6.5, and I got 7.2. And so on, I used the rest of those random x values to find out how many hours of sleep there would have been on that particular night on average, based on the linear model. If the linear model goes up, and the regular rate is 0.14 hours per night. If we really wanted to get into the details, we could translate that into minutes and seconds per night, but I like to keep things simple, so I left it at that. All right, I hope this is helpful. If it's not, I'm happy to support you as this project moves on. And I will see you back in school tomorrow. Thank you.